I am Monisha. I am doing my seminar on construction of DFA from NFA. Introduction of NFA. NFA is nothing but non-deterministic finite automata. For some current state and input symbol, there exists more than one next output state, and string is accepted only if there exists at least one transition path starting at initial state and ending at final state. And formula of NFA. NFA has 5 tulips, that is set of states, set of input symbol, initial state, final state and transaction positions. And here we have example of NFA. Example of NFA is in the above given diagram. We can see that when the current state is Q0 on input 0, the next state will be Q0 or Q1, and on Q and on one input, the next state will be Q1. When the current state is Q1 and input 0, the next state will be Q2, and on one input, the next state will be Q0. When the current state is Q2 on 0, input the next state is Q2, and on one input the next state will be Q1 or Q2. Here we have formula, that is input states are set of states are Q0, Q1, Q2, and input symbols are 1 and 2. Initial state is Q0, final state is Q2, and we are going to see the transition position, that is for Q0, 0 is going for Q0 and for Q1, and Q0 of 1 is going to Q1, and then Q1 of 0 is going to Q2, and Q1 of 1 is going to Q0, and Q2 of 0 is going to Q2, and Q2 of 1 is going to Q1 and Q2. And next we are going to see construction of DFA from NFA. Here we have a few steps to construct a DFA from given NFA. The following steps are: step 1, let Q be a new state of DFA. Let T be a new transaction table of DFA. Step 2, add state to the NFA to Q. Add transaction of the starting state of the transaction table T. If starting state makes transition to multiple tables for some input alphabets, then treat those multiple states as a single state in the DFA. Step 3, if any two state is presented in the transaction table T, add the new state in Q. Add transaction of that state in the transactions table. Step 4, keep repeating step 3 until no new state is present in the transaction table T. Finally, the transaction table T so obtained in the complete transaction table of the required DFA. And example of NFA from DFA is in the above given we have Q0, Q1 and Q2. Here Q0 have A comma B, and Q0 sends B to Q1 and Q1 sends B to Q2. By following the steps, we need to construct the NFA from DFA. After finishing that steps, we will get a transaction positions. By that we need to construct a DFA, and after that we will get a NFA positions, NFA transaction positions, that are Q0. From Q0 of A goes to Q0, Q0 of B goes to Q0 and Q1, Q0 and Q1 of A goes to Q0, Q0 of Q1B goes to Q0, Q1, Q2, and Q naught Q1 Q2 of A goes to Q naught, Q naught Q1 Q2 of B goes to Q naught Q1 Q2. Here the initial state is Q naught and ending state is Q naught Q1 Q2. And next we are moving to DFA. DFA refers to deterministic finite automata. Deterministic refers to the infinite automata are called deterministic finite automata if the machine is read the input strings on by at a symbol at a time. In DFA, there is only one path of specifying input from the current state to the next state. Does not accept the null move. DFA cannot change state without any input character. And next, DFA's example. Thank you.